So here's how you enable the mission editor and what's changed since last time. We have a list now, so you can enable a mission by clicking in. And we're trying our best to inform the form about what's going on in the game. So you've got the status badges off to the right here. And now let's switch to desktop and not UOBS. Let's get terminal up. And this is just the end of the non-technical part, by the way. Sorry, everyone, but that's basically it. That's what we're doing here. And in VS Code, you also get access to the same plugin. I guess that is also something that you can appreciate if you're using VS Code. You get the same live action out here. So if we actually unpause and then build
Battle resumed.
some pawns, let's turn no cost off too so we can see the update rate somewhat intuitively. About instant-ish. Anyway, this is all a mission server, a language server that renders its own UI. So this is a Rust live view in Dioxys, SSR in Rust. It's a live view pattern, zero client framework. It is taking this language file and parsing through a recognizer into an AST with byte spans and server-side rendering them through Dioxys. And that's just HTML that RMUI gets, all three terminals, the VS Code plugin, plus the browser display the same markup. And in-game panel is not quite as pretty as these. Like, it doesn't have quite the same styling, but it is exactly the same code. And the way we're doing that is the game participates just as a data source. The thing Watch the Fort was saying yesterday about having manifest, because it is mostly static data, was completely true. So that's what we do. We build a domain.json. Let me pull up so here's kind of the shape of how this works, right? We have a serve process here that is the language server and VS Code plugin and anything else we need. And it is reading the bar directory for the mission Lua files. So it is doing the same thing the engine is doing and in a read-only manner. And then it's compiling the form metadata and AST into a mission view.json, which is an accurate name. And then all three windows simply read from the same data source. Live values of the game are a little bit more dynamic. So we have a probe list that the language server is publishing that is like measure 5 pawns, watch the objective build pawns, and then game samples those live values, write state.json for those reduced parameters that the form has said it needed, and then it gets patched into the terminals automatically because this is all very programmatic and based off it just being typed Lua. This layer is where it gets really interesting though. So because this is just a subset or superset of Lua, we can expand or contract this layer however we need to express it. So we can have the grammar for our subset or superset of Lua express the restrictions we want in custom blocks and actually know what's going on in custom blocks because we have a parser. So we can do very deterministic checks for the community on things like modules that do potentially dangerous things, right? So this is a very important step that this 200 to 300 lines of code in Rust built on top of an Emulua parser buys us. We can restrict language features of our community and publish it in a way that they can consume without bar dev tools even. Domain.json is literally in this implementation just a list of units. That's all that is. State.json is these values columns we just talked about, writing back from the game to a little state file, and that's roughly what it looks like. This trigger is armed. It has, the JSON version, data structure version of this trigger state encoded so that the form knows where the game is at in those little status badges. Structure changes bump generation and re-render. That's basically all the terminals care about. Values just tick, and same form, all three windows, one render, and the Lua file stays yours. I think that's it. Let me know if you have any questions.